Hi, in this video we're going to be using the gas laws that we learned in the previous video in some problems. So let's say we have a sample of gas occupies 150 ml at 25 degrees Celsius. What is its volume when the temperature is increased to 50 degrees Celsius? So let's first write our P, V, T, and chart. Now we're going to write initial, final, and effect. So we're not dealing with pressure, and we're not dealing with the number of moles. So we're only going to look at V and T. Now the volume starts off at 150 ml. And then we're looking for the final, and we do not know the change. But if we look at temperature, it tells us we go from 25 to 50. But when working with these charts, you want to use everything in Kelvin. So 25 plus 273 is 298. 298. And 50 plus 273 is 323. So now this tells us that we go from 298 to 323. What does that mean? That means the increase in temperature. And now an increase in temperature. And now if you remember in the previous video, we said that Charles' law states increase in temperature means increase in volume, as they're directly proportional. So temperature increase, volume is going to increase as well. And now we're going to grab what we already have, 150, and multiply it by our ratio. And now how do you know which number to put on top? 298. Nope, this is wrong. We have 150. Now how do you know which number to put on top? 298 or 323? How is the ratio going to look like? And this is determined depending on whether it's going to be increasing or decreasing. In our case, our volume is increasing. That means we want a higher number from what we originated with. Now, in order to get a higher number than 150, we have to multiply it by a ratio that is greater than 1. So we can't use this one. And that means we're going to have to use the other one with 300, with a bigger number on top. So we're going to multiply 150 with a ratio of the bigger number on top and smaller number on bottom to get a number greater than 1. And our final answer will be about 163 milliliters. And yes, you stick to the rule of 3 over here. Now let's look at a more challenging example. All right, we have a 350 ml sample of gas has a temperature of 30 degrees Celsius and a pressure of 1.20 atmospheres. What temperature would be needed for the same amount of gas to fit in a 250 milliliter flask at standard pressure? Okay, so let's recreate this chart. PVTN. PVTN. And we have initial, final, effect. So first, let's write down all the information that we're given with. We have 350 ml, we have 1.2 atm, and we have 30 degrees, which we want to convert into Kelvin, which is plus 273, which is 303 Kelvin. Now we're not going to look at moles because the question didn't talk anything about moles. Now let's look at the final. So we turn into standard pressure, which is 1 atm, and our volume decreasing to 250 ml. What is our temperature? So now let's take a look. Pressure decrease, volume decrease. So both pressure and volume decrease. So now let's take a look at, let's compare pressure to volume first. So when you see a question where you're given with multiple columns to find a missing thing, you're gonna ignore one column and only do 2 of them at a time. So first let's start with V and T. We're only going to look at T and V. So temperature is 303. We're going to use that as our first number to start off with the proportion. Then we're going to multiply it by, let's see, volume decrease. What happens to temperature? As volume decrease, temperature decrease. So a decrease in volume will mean a smaller temperature. So we're going to put a smaller number on top. And then after we're done with the volume, we're going to stop looking at it and create a new proportion only looking at P and T. So pressure decrease, what happens to temperature? As pressure decrease, temperature also decrease. They're both proportional. So this time temperature also decrease. So we're going to put 1 on top and 1.2 on the bottom. Now I'm going to work this out. 303 times 250 times 1 divided by 350 divided by 1.2. And that gives me a final temperature of 180 Kelvin. Now this question did not ask us to write it in Kelvin or Celsius, so let's just do both. We have 180 degrees Kelvin. How do we get to Kelvin, from Kelvin to degrees Celsius? Well, we subtract the 273, right? So that gives us negative 93 degrees Celsius, and that is our answer to. That is the temperature that we're gonna find after we change the pressure and the volume. Now our final question. So this is a question here. And it's asking us if the volume increased or decreased. So here's what we have in the beginning, and here's what we have in the end. And what it told us is that in the beginning is 25 degrees Celsius and 1 atmosphere. After, it turned into standard temperature and pressure. What does that mean? Standard temperature is 0 degrees Celsius, aka 273 degrees Kelvin. So let's write a PVTN chart. This time we're going to only look at pressure and temperature. No, alright, sorry. Volume and temperature, not pressure. Because pressure did not change, right? It went from 1 atm to standard pressure, which is also 1 atm. So pressure did not change. We're only gonna look at, actually, if you do want to take a look, if you do want to write it, you can write atm, 1 atm, which is not gonna change anything. I'm gonna write initial, final, change. So it's neutral. Now we're mainly gonna look at volume and temperature. Volume, we're not sure what happened to the volume yet. We're not giving any volume information, but what we do know is that temperature went from 25, let's turn that into Kelvin first, plus 273, which is 298, turned into 0 Kelvin, which is 273. No, turned into standard temperature with 273 degrees Kelvin. Now, what happens to volume? As you can see, temperature decreased. So let's take a look at volume. As temperature decreases, volume decreases as well. So our explanation for this answer, and the question is over here, does the volume decrease significantly? Our answer here is volume will decrease because it has a direct relationship with temperature. And in this scenario, the temperature was decreased. So this is how you use the laws that we learned in the previous video, and these problems are going to come out quite a lot as we move on the unit. So make sure you know how to do these. Thank you for watching.